So this first question asks us to expand the binomial, but do not combine like terms. So that means we're going to get, and we could do it by the multiplication table, ax plus b times cx plus d is going to give us acx squared plus bcx plus adx plus bd, which gives us acx squared plus bcx plus adx plus bd. Okay, so if we do the same thing for this, we're going to get, if we have a is equal to 2, b is equal to 5, c is equal to 3, d is equal to negative 2, we get acx squared. So we get 2 times 3, or 6x squared. We get adx, so negative 4x, plus bcx, so plus 15x, and then plus bd, which would give us negative 10. Okay, so this is now, oops, this should be an x here. This is now equivalent to negative 11x, but we can also think of it as negative 4x plus 15, or negative 4x minus 15x, or 15x minus 4x. Okay, the point here is that we want to be able to think about the reverse of expansion, which is factoring. And so we want to be able to think about how we could take 6x squared plus 7x minus 3 and factor it into ax plus b times cx plus d. So we know that from above that ac is 6, bd is negative 3, abcd is negative 18. So we need two numbers that multiply to negative 18 but add to positive 7. And so that means we're going to end up with, let's say, 9 and negative 2. Okay, so that means we have BC equals 9 and AD equals negative 2. Okay, so as we continue with this, we then can now rewrite this whole thing as ACX squared plus BCX plus ADX plus BD. And so that means that we can rewrite this as 6x squared minus 9x plus 2x minus 3. Okay, and that means that we could now factor these first two terms to get 3x times 2x minus 3 plus 2x minus 3. So notice that we now have two terms, each of which has a 2x minus 3. When we factor that out, we end up with 3x times, we'll factor out the 2x minus 3. So let's take that out first. And what we're left with then is, let's put it in square brackets, we have a 3x. And then when we divided this by 2x minus 3, we just had a positive 1. So here's the factorization, 2x minus 3 times 3x plus 1. All right, so now let's look at a few of these where we're doing them on our own. And we'll start with this one. So we had 6x squared minus 7x plus 2. That means we need two numbers that multiply to 6 times 2, or 12, and add up to negative 7. So that means we're going to get negative 4, negative 3. And so that means we'll break our middle term into those two, minus 4x minus 3x plus 2, which means we can now factor out 2x here times 3x minus 2 minus 3x minus 2, which means we then have a factorization of 3x minus 2, and when that's factored out of the two terms there, we have 2x minus 1. Now notice if I had done it in the other order, minus 3x minus 4x plus 2, we're going to end up with 3x times 2x minus 1 minus 2 times 2x minus 1, and we end up with the same factorization of 3x minus 2 times 2x minus 1. Okay, so then we moved on to perfect square trinomials, difference of perfect squares. So let's look at what we were asked to do there. And the first one, so it's a perfect square trinomial, and the way we know is that the first and last terms are perfect squares, and the middle term is equal to double the product of the square roots of the first and third terms, or the negative square roots. So we have, again, the factoring pattern a plus b squared or a minus b squared, and this gives us a squared plus 2ab minus b squared, and this gives us a squared minus 2ab plus b squared. Sorry, that should be a plus. And so that means that in this case we would have 7x squared minus 2 times 7x times y plus our y squared. So we have a is equal to 7x, b is equal to y, or negative y, and so we're going to end up here with a minus b, so 7x minus y squared. Okay, when factoring, always try to look for any common factors that can be removed as a first step. So that means here we can end up with 3x times x squared minus 9, which means that we have a difference of perfect squares here, and that gives us 3x times x minus 3 times x plus 3. Okay, difference of perfect squares. We have one thing squared minus the second thing squared. So we know that a squared minus b squared factors to a minus b times a plus b. And so here we would get 3x minus 1 minus 2x minus 1, and put that in parentheses, times 3x minus 1 plus 2x minus 1. We don't need the parentheses there. This is going to end up giving us just a plain x. This here will end up giving us a 5x minus 2. And so finally we end up with 5x squared minus 2x. And that's a lot easier than expanding it first and then factoring. Okay, where do these curves intersect? The way we find that out is by setting them equal to each other, and because we're going to look for the point or points that satisfy both equations, so we want to find out where 2x squared minus 2x minus 1 is equal to x squared minus 10x minus 13. Then once we have our x's, we can figure out what our y's would be. So the methods that we have for solving something like this would have us setting one side equal to 0. So I'm going to subtract x squared, I'm going to add 10x, and I'm going to add 13, and so I end up with this. Now this is factorable to x plus 6 times x plus 2, so that gives us that x would be equal to negative 6 or negative 2. Okay, so it only asks us for the x values of the intersection points, so that's all we're going to produce here. Okay, next we have another intersection problem, but now we're supposed to find the x and y coordinates. So again, we're going to set x is equal to x squared minus 5x plus 5. Again, we want to set one side equal to 0, so we're going to set the left side, which is just much easier, x squared. We subtract x from both sides. This is factorable into x minus 5 times x minus 1, which gives us x values of 1 and 5. When I plug 1 in to either of my two original equations, I would get, and obviously the easier one is y is equal to x, so that's going to give me the points 1, 1, and 5, 5. We don't want to plug it into this because all that's going to do is give us a value of 0, which is how this whole thing got set up in the first place. Okay, next one, we again have these intersections, so we're going to set 3x squared minus 11x plus 6 equals negative 6x squared plus 19x minus 10. So I'm going to set the right side equal to 0, so I'm going to add 6x squared, I'm going to subtract 19x, and I'm going to add 10. So I get this, and then I need two numbers that multiply to, so 9 times 16 is equal to 144. So I need two numbers that multiply to 144 and add up to negative 30. Those two numbers turn out to be negative 24, negative 6. So I will set this 9x squared minus 24x minus 6x plus 16. And then I'm going to factor out 3x here to get 3x minus 8 minus 3 times 3x minus 8, giving me 3x minus 3 times 3x minus 8. And that's going to give me, oh, no, sorry. That's a 2 here, 2. 3x minus 2, 3x minus 8, and that's going to give me that x is equal to 1.5 or 8/3, or this is as a fraction 1.5. Okay, so now I'm going to plug those values back in to get my y value. So when I plug in 3/2, I'm going to get 3 times 3/2 squared minus 11 times 3/2 plus 6 is going to give me 3 times 9/4, which is 27 over 4, minus 33 over 2, plus, I know it's all going to be in fourths, so I'm going to make this 24 over 4. This is going to end up being 27 over 4 minus 66 over 4 plus 24 over 4, and that's all going to be equal to a total of, let's see, we have 27, we have 51, negative 15 over 4. So that's what goes with 3/2. So we have 3/2, negative 15 over 4. And over here, when we substitute in 8/3, we'll do 3 times 8/3 squared minus 11 times 8/3 plus 6. This is going to give me 3 times 64 over 9, so it's going to give me 192 over 9. This is going to give me 88 over 3, which is going to be 264 over 9 plus 54 over 9. And that's going to give me, let's see here, we have negative 264 plus 54 is negative 210, so negative 18 over 9. That gives me negative 2, so I'm going to get 8/3, negative 2. Now, you might want to check this on Desmos because I may have made multiple errors there. So you can also just find the y's by plugging into Desmos. Okay. Lastly, let's take a look at this one. All right, we're going to find the vertices and the vertex of the quadratic. So we're going to use the completing the square. And so we're going to say that negative 2x squared plus 5x plus 4 is equal to 0. And we want to use completing the square. So we're going to divide by negative 2 first. That'll give us x squared minus 5/2 x minus 2 is equal to 0. We're going to make this x squared minus 5/2 x equals 2. We're going to add 1/2 of this squared, so we're going to add 5/4 squared, and we'll add that to both sides. And when we factor here, we're going to get x minus 5/4 squared is equal to 2 plus 25 over 16. So we're going to end up with x minus 5/4 is equal to the positive or negative square root of 2 and 25/16, or 57 over 16. And that's going to give me that x is equal to 5/4 plus or minus the square root of 57 over 4. This should be a 16. and I turned the square root of 16 into the square root into 4. Basically, I said that this was true is equal to the square root of 57 over root 16 is equal to root 57 over 4. Okay, so then, because we're trying to figure out an area, we need to actually convert these into decimal equivalents, approximations, and that's going to equal negative 0.64 and a positive 3.14. The x value of our vertex is going to be exactly 5/4, and then we're going to plug that in to find out the y value of our vertex, which is going to be negative 2 times 5/4 squared plus 5 times 5/4 plus 4, and that's going to give me negative 2 times 25 over 16 plus 25 over 4 plus 4 is going to give me negative 2 times 25 is negative 50 over 16 plus, we're going to make this 100 over 16 plus, we're going to make this 64 over 16, and that's going to give us a net of 164, 114 over 16, 114 over 16, and that's equal to 7.125. Okay, so our triangle looks like this. We have negative 0.64 here, we have 3.14 here, and we have a height of this triangle of 7.125. And so that the base of this thing is equal to about 3.78 or so. And so we're going to end up with 3.78 times 7.125 over 2. And that's going to end up giving us a value approximately of 13.45. Okay, so the area here is 13.45. Number 5 is just the derivation of the quadratic formula, which I'm not going to do right now.